Now we are going to see about multiplication of vector by a scalar. Here when you take a vector, here it is multiplied by a scalar lambda. Then the answer is lambda a vector. If lambda is a positive vector, then the result will be along the direction of a vector. Suppose if it is a negative number, then the result will be in the opposite direction to the vector a vector. Here one example is shown for this. Here a vector is equal to 2i cap plus 3j cap. Then what is 3a cap? Just you multiply 3 with each and every term of the within the bracket. So here the answer is in the same direction of vector a, because this is multiplied by positive number 3. If it is given a negative number, then they will be in the opposite direction. And next, see this example. A vector is given. You have to find out 4a vector and minus 4a vector. For that, just draw a vector, and 4 times that will give you 4a vector, and if it is in the opposite direction, that will give you minus 4a vector. And there are some examples for this multiplication of vector by a scalar. Here when you take f vector is equal to ma vector, here m is a scalar and a vector is acceleration, which is a vector quantity, and here the direction of the force is always in the direction of acceleration. And suppose if you take linear momentum, p vector is equal to mv vector. Here v vector is velocity and m is scalar, and the direction of linear momentum is also in the direction of velocity. And this is the different case where f vector is equal to qe vector. Here the direction of f vector will depend upon whether the charge is positive or negative. The direction of force f vector is correspondingly either in the direction of e vector or opposite to the direction of e, depending upon the charge. And next we are going to see about scalar product of two vectors. The definition is the scalar product, the other name is called dot product, of two vectors is defined as the product of the magnitudes of both the vectors and the cosine of the angle between them. And you remember this equation, then you can write the statement by yourself. A vector dot b vector is equal to ab cos theta. And here the product quantity a vector dot b vector is always a scalar, that you already know. Even if you multiply two vectors, you will get only a scalar, and if it is positive or negative depending upon the angle. If theta is less than 90 degree, the vectors, then it is positive. If theta is in between 90 and 180, then the value is negative. And the next is the scalar product is commutative, that is a vector dot b vector is equal to b vector dot a vector, and that is you can multiply by any order. And distributive law, it obeys distributive law. A vector dot b vector plus c vector is equal to a vector dot b vector plus a vector dot c vector. And the angle between the vectors is given by theta is equal to cos inverse a vector dot b vector by ab. And here this is given by this equation, a vector dot b vector is equal to ab cos theta. From this equation you are finding out cos theta from that theta. And the scalar product of the two vectors will be maximum when cos theta is equal to 1, that means theta is equal to 0 degree. That is theta 0 means the two vectors are parallel. That means a vector dot b vector is maximum, that is equal to ab, because here cos theta becomes 1. In the next case, the cos theta will become minus 1, then the scalar product of the two vectors will be minimum. When it will become minimum? When theta is equal to 180 degree, because you know cos 180 is minus 1. So a vector dot b vector minimum is equal to minus ab, which means the vectors are anti-parallel. Anti-parallel means they are in opposite direction, then only theta becomes 180 degree. If the two vectors are perpendicular to each other, you know cos 90 is 0, so a vector dot b vector becomes 0. In such a case, the two vectors are said to be mutually orthogonal. Orthogonal means perpendicular. Then self dot product, that is two vectors are multiplied, that is a vector is multiplied by the same vector. A vector dot a vector is equal to aa cos theta. Here it becomes a square, because the angle theta is equal to 0. And the magnitude a is given by square root of a vector dot e vector. And in the case of unit vector, just to remember, if a unit vector is multiplied by the same unit vector, that is I cap dot I cap, then j cap dot j cap, then k cap dot k cap, that will become 1 because angle is 0 for the same unit vectors. So cos 0 is 1, so it will come as I vector I cap dot I cap is equal to 1. Whereas in the case of orthogonal unit vectors, theta will become 90 degree, so I cap dot j cap must be equal to j cap dot k cap, that is equal to k cap dot I cap is equal to 1 dot 1, because for unit vectors a and b will be equal to 1 and the angle is cos 90 degree. You know cos 90 is 0, so the I cap dot j cap, that is when you multiply the other vector, then that will become 0. And when you take in terms of components, a vector dot b vector, you split up a vector into its component and also b vector into its component. Here when you multiply I and I, you will get 1, whereas when you multiply I and j, you will get 0. So the terms will come as ax bx plus ay by plus az bz, because all the terms other terms will become 0. And the magnitude of a is given by the formula square root of ax square plus ay square plus az square. Next, vector product of two vectors. Here the definition is the vector product or cross product of two vectors is defined as another vector. That is, when you multiply two vectors, you will get only a vector in cross product. You can call it as vector product or cross product, and the magnitude is equal to the product of the magnitudes of two vectors and the sine of the angle between them. So here the formula is, if C vector is equal to a vector cross b vector, which is equal to ab sin theta n cap. So instead of cos theta, in cross product you will get sin theta, and additionally you have unit vector n cap. And what about the resultant? The resultant is perpendicular to the plane containing the two vectors in accordance with the right hand corkscrew rule. And you see this diagram. Suppose if we take C vector is equal to a vector cross b vector, and here when you advance the screw from a to b, that is you are moving the screw in the direction from a to b, then the advancement of the screw will give you the direction of C vector, so it will be upwards. And suppose if we take in this diagram, here minus C vector is equal to b vector cross a vector, because here the screw is advanced from b vector to a vector, then the advancement of the screw is in the downward direction, then that will become minus C vector, because in the upward you are having C vector, whereas in the downward you are having minus C vector. So minus C vector is equal to b vector cross a vector. From these two you can say that it is for not following commutative law. When you change the order, then the result will have the negative sign. That is a vector cross b vector is equal to minus b vector cross a vector. So this is about the vector product. So in vector product, you should use a sine cross sine, and also instead of cos theta, you should write a sine theta and n cap. And what about the resultant? It will be perpendicular to a plane containing both a vector and b vector. And when you see this a vector and b vector, and so in the advancement of the right-handed screw rotated from A to B vector through the smaller angle between them. So you are following the right-handed screw rule for this. And so similarly for B vector cross A vector, we should follow the right-handed corkscrew rule. Definition that will give you the first property, and here the A vector and B vector can be orthogonal to each other. It may or may not be mutually orthogonal. When you take A vector and B vector, they can be orthogonal or may not be orthogonal. And the vector product of two vectors is not commutative, because A vector cross B vector is not equal to B vector cross A vector, but the sign will be changed. And so here you know this formula, A vector cross B vector is equal to B vector cross A vector. When you take modulus, that will give you AB sin theta. So the magnitudes are equal for both A vector cross B vector and B vector cross A vector, but the directions are opposite to each other. And here also the vector product of two vectors is maximum when sin theta is equal to 1. But sin theta is equal to 1 when theta is equal to 90 degree. So when the vectors A vector and B vector are orthogonal to each other, then it will be maximum. A vector cross B vector maximum is equal to AB n cap. And if they are non-zero vectors, they will be minimum when sin theta is equal to 0. Sin theta is 0 when theta is equal to 0 or 180 degree. Then in that case, A vector cross B vector minimum is equal to 0. And in vector product, the non-zero vectors vanishes. The product of non-zero vectors vanishes if the vectors are either parallel or anti-parallel. That means when the angle theta is equal to 0 or 180 degree. And in this self-cross product, the self-cross product will become 0, but it is 1 in the case of dot product. Here A vector cross A vector will gives you AA sin 0 n cap. Since you know sin 0 is 0, the entire product will become 0, which shows that the self product will become 0 in the case of vector product. And so here also the self product, that is I cap cross I cap, that the self product will become 0 in the case of vector product. But orthogonal vectors, that means I cap cross J cap will give you K cap. In circular path you take J vector cross K vector is equal to I vector, and K cap cross I cap is equal to J cap. So you take in the circular way as in this diagram. And here when you take in the opposite side, that is instead of I cap cross J cap, if you take J cap cross I cap, you will get minus K cap. Because when the order is changed, so it will give negative sign. It will take negative sign if the order is changed. And in terms of components, you should write this in matrix form. A vector cross B vector is given by modulus I cap, J cap, K cap, AX, AY, AZ, BX, BY and BZ. And how can you find the determinant? Determinant I cap into, you know, this in the, you have studied this in your 10th standard, AY BZ minus AZ BY. Then for instead, in the case of J cap, you change the order from bottom to the top. That is AZ BX minus BZ AX BZ and K cap into AX BY minus AY BX. Just you find the determinant. And so if the two vectors form the two adjacent sides of the parallelogram, suppose if we take A vector, B vector, they are as the sides of the parallelogram, then you complete the parallelogram, then the area of the parallelogram will give you A vector cross B vector. And so A vector cross B vector is given by modulus A vector modulus B vector into sin theta. So here the modulus, or you can take the magnitude of A vector cross B vector is given by the area of the parallelogram. And similarly, if you take the sides as the triangle, here A vector and B vector, they are taken as the sides of the triangle, then the resulting is the opposite side. Suppose you complete the triangular, then the area of the triangle will give you A vector cross B vector by 2, because it is half of the parallelogram. Here in this, the full area is A vector cross B vector. Here only the half the parallelogram. So A vector cross B vector divided by 2. So here you can for vector product you have several examples. Torque, angular momentum, they are vector products. When you see the example, torque is given by tau vector is equal to R vector cross F vector, where F vector is the force and R vector is the position vector of the particle. Similarly, angular momentum L vector is equal to R vector cross P vector, where P vector is a linear momentum, and linear velocity V vector is equal to omega vector cross R vector, and here omega vector is angular velocity. So these are the examples for cross product or vector product. And you are given two vectors, R vector and F vector. You have to find out the resultant vector. Here tau vector is given by R vector cross F vector. You write it in the matrix form, and if you find out the determinant, that will give you the answer. Just you leave the I cap column and row, then you multiply 3 and 4, 3 and 4 12, minus 5 into minus 2 will give you minus 10 into I cap. Similarly for J cap, but you take the reverse order. And similarly for K cap, you write that, and you will get the resultant as 22 I cap I cap plus 7 j cap minus 13 k cap. Suppose you take components of vectors. Now we are going to see about the properties of components of vectors. Here if a vector is equal to b vector, then the components also equal. That is, when you split up a vector into its component, you will get ax I cap plus ay j cap plus az k cap, which is equal to bx I cap plus by j cap plus bz k cap. Then the components will be equal. So ax is equal to bx is equal, that is ay is equal to by, and az is equal to bs. So the individual components will become equal. Now compare the components for the following. F vector is equal to ma vector, where m is positive number, and p vector is equal to 0. First you take this case, f vector is equal to ma vector. You split f vector into its component and a vector into its component. When you split f vector, you will get fx I cap plus fy j cap plus fz k cap, which is given by m ax I cap plus m ay j cap plus m az k cap. So you have to multiply each and every component by m in the right hand side. So comparing the components of I cap, j cap and k cap, that is, you just leave I cap, j cap, k cap, then equate, then you will get fx is equal to max, fy is equal to may, and fz is equal to maz. The next you take p vector is equal to 0. Now p vector is split up into its component. So px I cap plus py j cap plus pz k cap, which is equal to 0 I cap plus 0 j cap plus 0 k cap. Now you compare the components, then you will get px is equal to 0, py is equal to 0, and pz is equal to 0. Just you are comparing the components. And next you find out the value of the t from the given vector equation. 5 j cap minus t j cap is equal to 6 j cap plus 3t j cap. In that you bring 6 j cap this side. So 5 j cap minus 6 j cap is equal to 3t j cap plus t j cap. And you leave just the unit vector. So you will get 5 minus 6 is equal to 3t plus t. So minus 1 is equal to 4t. So t is equal to minus 1 by 4. And next you take this equation, you are going to compare the components. f1 vector plus f2 vector plus f3 vector is equal to f4 vector. So you resolve. Resolve means you are splitting. You are splitting all the vectors into y, x, y and z components with respect to Cartesian coordinate system. Then you will get f1x plus f2x plus f3x is equal to f4x, and similarly it will go on. So all the x components are equated, all the y components are equated, all the z components are equated. So we are resolving the vector in the system of Cartesian coordinate. Hope you understand these problems, girls.